DTU. Now we are recording. Okay, over to you, sir. Now it's all yours.
Okay, all right. Okay. Hello. Can you hear me? Can you hear
Yes,
me?
we can hear you, sir.
Okay, good. All right. I'm going to talk about our work on designing ecological buildings and master plans. And I call this Ecotopia. That is, our goal, which is to do a utopia that is ecological. And so our work is how can we repurpose and remake our built environment for a resilient planet. You see, the cause of today's environmental devastations and impairment is due to our built environment and its technologies. So I use the term built environment very loosely. It covers not just our buildings, our cities, but it covers everything that we make and do as human beings. Our technology, our artifacts, our production of energy, our production of food, and so forth. So built environment is everything that is made by human beings. Now, this is the way I do our work. We usually define the objectives for what we do. We do research, and then on the right-hand side, we try to interpret it by design, and we test in some of our built projects as prototypes. And then we evaluate and we publish these, and these leads on to further research. So this is really like a cyclic process of how we work. I've been doing this for nearly 47 years, and so it's been a journey for me. But I still haven't completed my full lifetime agenda. But this is what you see today is as much as we got, as far as we have got. Now, ecologists, what differentiates our approach from that of other green architects is that I'm both an architect and ecologist. So we look at the ecological, look at a design for resilient planet as an ecologist, and from the ecocentric point of view, based on the science of ecology. Why do I do this? Because at the end of the day, the baseline for everything we do is the ecology of the planet, the biogeochemical cycles, the energy and material resources, our ecosystems. Now, if you look to any of these certification or accreditation systems, whether it's LEED or Green Mark or CASB, the great emphasis of these are on the technological aspects. Whereas we should start with ecology, because once we start with ecology, it encompasses everything. It is much more holistic and comprehensive. And so ecology sees the Earth as covered by a thin film called the biosphere. And then within the biosphere are ecosystems, which are units in nature. And the biosphere consists of communities of plants and animals and the physical environment. So the community of plants and animals are just the plant community, the plant, not just the plant, but the animal community of plants, animals, and microbes. And then a site is the physical environment is a site characterized by given climatic factors and features, and its geology and its edaphic factors or its soil. And so the biosphere the ecosystem consists of biological constituents and physical constituents acting together to form a whole. Now, within the biotic constituents are human beings, our human beings and our communities. And then there is the physical environment of which we make things. This is our built environment. And as human beings, and as one of the species in nature, we make more things than any other species in nature. We will cover almost, at least a significant portion of the planet with our built environment. We throw the things that we don't want into into the biosphere, or we call them withdrawing. People say, oh, let's throw this away. But in effect, there's no away. Everything that is away is within the planet. And so this contaminates and pollutes the planet with the stuff that we don't want. And so if you live near the sea, then you find that every day the sea washes plastic stuff that we throw away into the sea, and which gets washed the beach, and that the aquatic life eats it and kills them and affects the life of the aquatic ecosystems. Now, as I mentioned earlier on, the built environment is everything that humans make. Our cities, our urban areas, our buildings and structures, transportation systems, artifacts, and food, and so forth. If you like, this is a model of what is happening now. Our built environment is a central square. It takes in inputs of energy and materials from the biosphere and throws out outputs, and outputs goes back to the biosphere. And if you look at it a little bit more comprehensively, inputs consists of energy, water, materials, food, and people as well, and their transportation. And the built environment has impact when they make it, and that's the impact when you use it, and that's an impact at the end of its useful life. And outputs are obviously energy, emissions, materials, waste, people, the built system itself and its useful life. And now everything goes into the biosphere. Now it is the ineffective integration of our built environment with the biosphere that's the cause of current state of environmental impairment. And because of this, for example, the gases that we emit from the production of energy goes into the air, it pollutes it is not integrated into the atmosphere, and this is the cause of pollution. In many ways, I see what we do as architects similar to what doctors do in the design of prosthetic devices. Now, a prosthetic device is an artificial object. It is like an arm or a heart or a leg or a kneecap or even an eye, which is attached to a host organism. The success of the prosthetic device depends entirely on effective biointegration. So if we draw the analogy, then our built systems and technology artifacts are prosthetic devices because they're human-made, they're artificial, they're synthetic. And our equivalent host organism is the biosphere and its biogeochemical cycles and its natural systems. So then everything depends on effective biointegration. If the biointegration is ineffective, then it's the cause of environmental disruption. So that is, in one single diagram, a summary of what we're trying to do is to try and effectively biointegrate our built environment with the natural environment in a seamless and benign way. Now, what does this mean? Biointegration, to me, there are two aspects. One is physical and systemic. Physical biointegration is very simple. It's just placing it and joining it together. But systemic is the more complex one. So what I'm trying to do in our work is to see whether we can create hybrid ecosystems that by imitating and emulating the attributes of ecosystems. And so one of the first things we try and do is to list down what are the ecosystem attributes that we need to emulate and replicate. So for instance, you have the ecosystem attributes include biological structure, biodiversity in ecosystems, connectivity in ecosystems, the provision of ecosystem services, the biointegration in ecosystems. Ecosystems respond to climate, ecosystems respond, use and recycle materials, ecosystems produce pure water and bring the water back to the ground. Ecosystems, the species are symbiotic. There's homeostasis, a feedback system within ecosystem, and ecosystem produces own food and ecosystems succeed over a period of time. So then our work starts with how can we emulate and replicate these attributes. So the first thing we did was to look at ecosystems biological structure. Now this was the diagram that I showed earlier on, that the ecosystem consists of biotic and abiotic constituents. But what you find if you look around you in Mumbai, for example, that the environment that you're in, the building that you're in, is mostly abiotic. It is hard, it is masonry, it is concrete. Then where is the abiotic constituents? And so this is what differentiates our built environment with the ecosystems in nature, because nature has a complement of both biotic and abiotic. Now this is a very important factor, because once you consider this factor, then obviously if you want to create your buildings to be like ecosystems, then you should have its complement of biotic constituents. And so our work starts with then, how can we bring biotic constituents into the built environment? I've done, there are 4 diagrams here. The first one is to put it all in one location. As you can see in Central Park, you can have a spotty relationship as in the second diagram, as in Georgian London, where you have a series of green squares, Euston Square, Bedford Square, Tavistock Square, Russell Square, and so forth. Or you can have a stepping stone relationship. That means you have green patches which are close to each other, like a stepping stone, but not exactly connected. And finally, the last diagram is the preferred one, because all the green areas are connected. I have green corridors and green fingers that eat into the built environment. And by being continuous and enable species migration, enable species interaction. By being connected, you have a greater pool of natural resources to be shared among the species. And so ecological design, this is the preferred pattern, continuous planting. Now, continuous planting is not just at the ground plane. We should try and link it as possible, but we should link from the ground vertically into the built system like this. And so this is my idea of the green city, that it starts with biointegration of biotic constituents, the greenery, with the abiotic, which is the physical environment. And this must be done in such a way, not just you use any species. The species must not be invasive, because if it's invasive species, it could affect the ecology of the locality. And so I started to experiment with this and see how we can bring it up, into the building, not just in a sporadic fashion, but we should bring it all the way down to the ground and to the basement as well, in as much as we can. And so these are the key factors in balancing the biotic with the abiotic. Vertical ecological corridors, interconnected greenery, connecting green patches within the city and green within the building, which we link to the hinterland and we link to the basement levels. So this is the scheme that we designed in Singapore. It's not built yet. It is the EDIT building. And the idea was to have a ramp of greenery that goes all the way around the whole building and on the outside of the building. So it's continuous. So this is representative of this earlier diagram. Here's the perspective of the building. And these are a set of plans that show the greenery going all the way up. Then the idea was that whenever the greenery reaches the same level as the adjoining building and the roof level, we should try and bridge across it and then extend the greenery into the roof. So in this way, our building then becomes a catalyst. Our building becomes a device for slowly greening the entire city. So this is just an idea that we had for doing it. Now, the next property, ecosystem attribute, is ecosystem biodiversity. Ecosystems don't consist of just one species. If you look into the building that you're in and the room that you're in, all you have is yourself, human beings, as the primary species, and then the other species are the rats and the rats and the creatures and the cockroaches and the microbiotic life in the room that you're in, or in the environment that you're in. Now, how do you enhance the biodiversity? And so our approach then is to see that whenever we design, we try and create habitats within the built environment at the ground plane. And so the habitats could be, as you can see on the right-hand side, green roofs, vertical greening, green sky courts, green atriums, a constructed wetland, detention ponds, bioswales and green areas on the ground. And then there should be green links to the hinterland. And also there is, when it goes down to the ground, we call it the Ecocell. This building was completed about 3 years ago, and it's quite a big building. It was basically 2 buildings, which are almost symmetrical. And they lie in between. There's a boulevard, which is linked in an axis to from the plaza at the north all the way down to the monument on the south. So the second bar that you can see on top, or you can see the upper diagrams, are the different areas where we create habitats: the ground plane, on the terraces, on the walls, and so forth. So having established habitats in our design, we start to look at the biodiversity, and this site is about 3 degrees above the equator. As you can see, it's fairly biodiverse. And we started to prepare what we call a biodiversity matrix, which is this matrix on the left-hand side. On the first column, we have the species that we want to bring back into locality, species of fauna that we want to bring back. And then the top bar are the habitats. And we see how they interact with each other, whether it's for feeding or breeding or for prey. And then from there, we identify floral species that will attract the fauna. And so in this way, what we have is a matrix of habitats, flora, and fauna. Then we use this as a basis of designing the landscaping and the habitats for the development. So in this way, the whole development then becomes a biodiverse development, where everything is, we try and balance the biotic with the abiotic. So you can see the 2 V-shaped buildings, and they sit on this piece of land, which is about 3 acres, between the plaza in the center, and then going down on the far left to the monument by the waterfront, which is also designed by us. And then in the middle is the bridge, and the right-hand side, it leads to Prime Minister's residence. So here it is. You can see the 2 buildings, and you can see the square and the monument, which is on the right-hand side, which is next to opposite the Ministry of Finance buildings. This is the space in between the 2 buildings. It's a seating area for people. We intend to make this into a space which is a place with a lively space for people. And then off this, below the towers, are canopy spaces which we hope to have restaurants and bars and food and beverage outlets. Now, what is unique about this building is this double skin. You see, the conventional way of treating sun shading is to have horizontal louvers. But we wanted to do something besides horizontal louvers, and we thought we'd experiment with the idea of fritted glass, which is the glass with a fritted pattern on it. It's not exactly butt jointed, it is spaced a little bit further apart. And the fritting is about 50% fritting. And then it is the outer, there's the 2 skin, that's the outer skin, that's the inner skin. So the outer skin, this is what it looks like from the outside in the left-hand diagram. Then the second image is looking out from the walkway between the outer skin and the inner skin. And then the right-hand side is the view of the outer skin altogether. Now, we wanted to see how effective it is as a sun shading, And the building energy intensity is 136.18 kilowatt hours per square meter per annum, whereas the typical office building uses, as you can see, 210 kilowatt hours per square meter per annum. So by all means and purposes, this is an effective and low energy building. So these figures actually show that the filtered glasses and sun shading works. On the west side, we wanted the angle to protect the building from the west sun, so we angled it to face the west, and this is the western side. And so in effect, when you look at this building, you can tell how it's orientated, because this once you see this, you know it's the west facade, and you see the other side, which is the northeast facade. But this time we brought all the greenery all the way down to the basement, and we call this an Ecocell. This is the master plan we did a few years back for the Kowloon waterfront, and these are the Ecocells on the podium, which cut all the way down into the basement, and it does the following things. It provides vertical integration for the greenery, provides opportunities for rainwater harvesting, brings natural ventilation to the lower areas, it brings daylight into the lower areas, and you can have an eco machine at the bottom, or a bar swale, so that this is used for treating its sewage and its waste. So I call this an Ecocell. This is the device we have in the buildings. And so for this particular project, you can see the planting going all the way around from the third level, spiraling all down to the ground, down to the basement. And so this is the Ecocell. And this is the view of the building from a distance. You can see the promenade in between, and the two blocks, and the facade at the side. Now, what we notice is that nature is totally interconnected, and sometimes not just physically, but also by the air and by the water, even though these are not immediately apparent to all of us. And so one of the things we try to do is to reconnect nature, because what human beings do is that we fragment nature, we cut whenever we go on a site, we fragment nature by roads and drains and sewerage, and we should try and reconnect it. So in this scheme, we try and look and see how we can reconnect the green areas in this building by this ramp. On the left-hand side is the inspirational drawing that we did to show that the greenery is by this ramp that goes all the way up. Then next to it, we have a walkway. The walkway enables you to service the greenery without going through the building. And that this is a detail of what it looks like. You can see the walkway, you can see the vegetation on the left-hand side, the sun shading on top. And so, actually, as by now, it would be evident to you that all our projects are experiments. They're not 100% perfect. They're aspiration of what an ideal built environment could be. Ideal environment would have linked greenery and walkways on the outside. And that eventually we got this built back in 2006. And here you can see the walkway, people walking, and the planting, and the sun shading on top. But what we do is that with every facade, we climb up one floor. So eventually we spiral, the vegetation climbs all the way up to the top of the building. You can see the ramp over there, and that the ramp has vegetation on one side and a walkway. And that you can see that at the corners we open out into sky courts. We have a mid-level garden and a garden on top. And then at the far corner we have what we call sky courts, which provide if you like, transitional spaces between the inside and the outside. So in this way, people from the inside can actually integrate or can interface with people along the walkway. And we call the walkway a linear park because it extends about 1.5 kilometers long when stretched out. And this is what one of the terraces look like from the from the corner. And then we have a mid-level garden. Then from the mid-level garden, then we have a roof garden at the top, which gives a panoramic view of the entire surrounding. Now, the green area ratio to get the green mark accreditation is 6. It has to be more than 6. But for this project, because of the green ramp, we've exceeded 6. We got 12.2 green area. Between the buildings is an atrium, and the atrium opens out into it's basically 2 blocks linked by a bridge. And on top of the atrium, we have louvers which are open, so that on a normal day, these louvers are open to let the wind through and let the air through, and that we didn't need to fully air condition the atrium. And then in inclement weather, when there's rain, the louvers automatically shuts. And so the bridges link the 2 buildings. Here it is, one of the bridges, and then one of the experiments we have is we created this, what I call a diagonal light shaft that goes all the way up from the street level down to the top of the building. And the right-hand side, you see how it opens out into the atrium. This is looking up from the ground floor, and this is looking down from the upper floor into the street. This is a simulation of the daylight conditions into the floor. I'm afraid this is not a very good example of energy efficient floor, because you can see the blue color shows that centers of the floor plate does not get full light. We maybe should have made the floor plate much more thinner. In Germany, the distance between glass to glass is about 15 to 17 meters. And here we've actually have more than 17 meters, especially on the right-hand side block. But daylight comes in at the edge, so the yellow color shows the daylight entering the building. But the Ecocell, the diagonal light shaft in the middle of the left block brings some daylight into the middle of the building. Now, from the Ecocell, we have vegetation that goes all the way up, climbing every floor with this ramp, and that it ends in the Ecocell, as in the previous building. It weaves the vegetation weaves all the way down to the ground, and so that is this building. So on the right hand side is a diagram that shows how it works. The vegetation starts from the Ecocell, weaves its way up to the top, to the mid-level garden, and to the top of the building. Now, how do we create habitats in a high-rise built form? This is the building that is under construction now. It is an apartment building. And what we have is a green wall that starts from the ground, going all the way to the top. And we start the design by looking at the surrounding areas. What are the greening that we have? Which are the species around the area? And we try and bring species back into the site, so that the site, which has been fragmented and simplified by human beings. So then, as I mentioned earlier on, we try and create habitats within the building, and then we stratify the habitats. So for a vertical building, for the lower part of the site, we have dragonfly. For the middle part, we call it the butterfly zone. In the middle part, we call it the songbird zone, and the upper part is the migratory bird zone. So these are the different stratification. And if you like, this is the biodiversity matrix for a vertical building. You can see the birds that we want to, migratory birds, with the songbirds that we want to bring into the site, and so forth. Now, this property of the ecosystem is called the provision of ecosystem services. That's probably the most important ecosystem attributes that we should try and emulate and replicate. Now, what is ecosystem services? Ecosystem services are services that nature provides for us as human beings without human intervention. Nature does it for free. Nature does it without telling nature to do it. And these are some of the things that nature does for us. Nature produces oxygen, it maintains biological and genetic biodiversity. And this is I won't read through this, but it's the whole list of things that nature does for us. So in principle, we should try and emulate and replicate this. But then it became clear that it is almost impossible for us to do this because there's no way we can produce enough oxygen for the entire planet, or the genetic diversity, or purification of water and air. So how do we do this? Even you have the best technology in the world, even you use the best sources of energy, it is totally impossible to do this because it's so extensive, and nature does it in such a very clever way. So, like as example, nature produces oxygen from photosynthesis. The emissions from our energy production systems are assimilated by nature. It's impossible for us to simulate everything, and so in nature is connected, and this is something that I mentioned earlier on. So my idea then was that what happens if we bring nature not just like the squares in Georgian London as a series of fingers that eat into the city, and we weave the green areas and the urban areas like two clasped hands, so that that the nature that is woven into the built environment can provide biodiversity services to the urban areas. And so this site is by the sea, so we have a spine that collects all the species, and then we have a series of fingers going up into the land, and then from the land we have the black color shows the urban areas, which then goes out weaving into the red areas. We designed this with about 30 meters spacing between the green areas, and the green areas are about 20 meters wide. So in this way, we're generally able to bring green areas into the built environment. But it's an idea. It's a way of interfacing the greenery and the built environment in a weaving pattern. So by doing so, we enhance the ability to provide ecosystem services within the built environment. We call this augmenting nature. Nature is augmented into our built environment to provide ecosystem services. Of course, the edges should not be pristine, as you can see in the top right side, because if you ziggurat, if you shape it and it's irregular in shape, it gives spaces for species to hide, species to create their own homes. But if it's straightforward, it's straight, then it's not so effective. Next thing is boundary system integration. Now, this is where I talk about infrastructure, because this is an existing city. The black dot is where the sources of energy or the water comes from, and then we had the triangles show built structures. But what architects now are doing is we build green buildings into the city, and which is good. Nothing wrong with doing that. But what is clear is that if the infrastructure itself is not green, then everything else you do makes it extremely difficult to make the city green. So the question then is, the challenge then is, what happens if we start with the infrastructure? Then it's much easier that everything we build becomes integrated as a whole. And so, this idea, this concept, this thought, if I were to leave one thought in your mind, is that we should start with infrastructure and make green first. Then we do green buildings. But if you do it the other way around, as you see in this diagram, then it is almost impossible. It will take you years and years and years and years to change all the existing buildings to become green. Now, what are the infrastructure that we need to biointegrate? The first is nature. Nature itself, we can regard nature as an infrastructure, the ecosystems, the waterways, and so forth. Then water itself is part of nature, but I take it up because the hydrology of a locality is extremely important, because water is what life is all about. Without water, no species can survive. When astronomers look into the sky, look into the moon, and look into Mars, the first thing they look for is whether there's signs of water. And if there's signs of water, it means there's organic life. Then the next infrastructure that we need to consider is human society, human society, is not just human beings as a species, but our societal systems, our social systems like economic, political, educational, institutional, and manufacturing and transportation systems. And so, this is the third infrastructure that we need to consider in ecological design. And finally, there's the built environment, which is the enclosure of systems, the technology. And that ecological design is how we can bring all these together into a whole. Now, obviously, this is easier said than done, but this is the principle of what ecological design is about. Biodegradation of these four infrastructures, the humans, the human society and systems, built environment, everything that we make and do, and there's nature, and there is water. So to illustrate this is a project we did in Bangalore. It's a master plan for in Bangalore. You can see it's right next to a green area. And so the first thing we did was to have a spine that collects all the green areas. Then we stretch it across the site so we can link the green from the far left, right-hand side to the far left of the site. So we traverse across the site by these so you can see the green fingers that goes across. And this is the eventual master plan. You can see the green areas on the left-hand side, and we stretch it across the site to go across the adjoining sites. This is the road system, and the road system has a bridge. It's from the left-hand side, the right-hand side. So it goes across the site and to the adjoining building. This is the road structure. This is the water which follows the road. And so in the composite of biodegradation, you can see the water, which is the blue, and the road, and then the human society movement systems in the red dotted line, and then the green represents the green fingers. Now, ecosystems hydrology is about water and how water falls in the land. In principle, the water falls in the land must stay in the land. You should try and bring it back into the ground, as well, through bioswales or through rain gardens as much as possible. So in this project, you can see the white square where the detention ponds are that brings the water back to recharge the groundwater. But it's a diagram of what we should try and do. That within the built system itself, we should try and close the loop as much as we can. We should reuse water and recycle it. And then things that we cannot use, we throw it, we dispose it to the outside. But also on the outside, it means it goes into constructed wetland, it goes into a bioswale, into the bioswale. Here's the diagram of the water within the built environment. But when it goes outside, we should try and integrate into the outside. And so this is both the internal and external relationship between the water and the environment. On the right-hand side are some examples of how we can bring it back into the ground, whether through infiltration planters, through permeable paving, infiltration of bioswales, rain gardens, and storm water and wetland canals. For the black water, we should have it to flow through a series of natural process of treatment plants, treatment areas, so that the water then gets increasingly more difficult to be thrown away somewhere or just interconnected but brought close to each other. Now, ecosystems respond to the climate. So that means the ecosystem that we have, let's say, in the Northern Hemisphere, like in UK or in Beijing, is very different from the climate in the tropics and the hot humid tropics or in the in-between areas. And so these are the different climatic zones within the planet. You can see the equator, and then above the equator are the temperate climate zones, and then finally the cold climate on the uppermost part of the from the equator. Now, in a normal, in the temperate zone, you have basically 4 seasons. You have winter, a very cold winter, and a hot summer. But in between are the nice times of the year. I call the mid-season, which is the spring and the autumn, and that. And so the blue line indicates the comfort conditions in winter and in summer, and then the red line indicates what engineers do for us. They try and have consistent temperature, humidity, and air change throughout the whole year, which makes mechanical systems a very high energy systems. And so we call this full mode. That means it is 100% consistent temperature and humidity and air change. Now, bioclimatic design means designing with the climate locality. That means we can increase the comfort conditions in winter a little bit, increase the comfort conditions in summer a little bit by proper orientation, facade design, and the shape of the building. So the different strategies you can see on the right-hand side. And then mixed mode means some mechanical systems, such as you can use ceiling fans or exhaust fans. And then productive mode is where you start to use renewable sources of energy to try and generate your own energy. But what is clear is that with all these low energy solutions, whether it's bioclimatic, bioclimatic and renewable sources, you can never equate with the red line, which is the mechanical system. And so it's not 100% solution, but that's one of the ways of doing it. Now, this is the project we did in the temperate zone. This is in London. But what we've done is that we created a flue wall that starts from the bottom going all the way up to the top of the building. And because the dry bulb temperature between the outside and the inside is significantly different, that creates a buoyancy between the inside and outside. You cannot do this in the tropics because the temperature, for instance, within the shade and within the outside is almost similar. But here, because of the buoyancy in temperature, it sucks the air during the mid-season from the mid-season from the lower floors all the way up to the top of the building. So now, what is the current state of our research and development? This is the diagram that I showed earlier on. We define our objectives, we do research, design interpretation, and we test, we build projects. And so, if you like, and this, these are some of we've covered those items which are called further development. We cover those items which are trying to emulate and replicate, but it's 100% perfect. We still need to do further development. And then the bottom, like ecosystems and biases, hemostasis, reproduction, and succession. Our work on this is in progress. So that's a summary of our work done to date. There's a full agenda which we haven't completed, but we're still working on it. Thank you very much.
Thank you, Dr. Kent. It was really insightful. In fact, going through all of these things, we realize that this is something that we need at the moment the most. We need to, have a fine balance between the built environment and the ecological, sustainable, whatever factors will help us live a bit longer and a better life. And just to wrap the conversation and bring in a couple of questions which we saw during the musings event where we were originally to have you and have the keynote. There were a couple of questions that people were sending in, so we just thought that we will just rush it through you and see what your responses are.
Sure.
So in one of the interviews you had mentioned that humans are fickle-minded creatures, so you should never design iconic architecture for the sake of it. It should be something which is built that will last longer and will have a better result. Could you give your comment a bit more on that, how students can understand it better?
Well, I don't think we should tell what other architects should do with the aesthetics. It's like too autocratically to that. But what's important is that whatever you put in to make your buildings iconic, or whichever features you put in, you should try and justify them. You should rationalize them so that they contribute to either as lowering the energy or enhance the ecological performance, the ecology of the project. And so we should not have gratuitous iconic features. But on the other hand, ecology is only one of the factors that that we need to consider in design. And so for me, there are four factors. First one is that the design must work, it must be functional. If the design is not functional, then it's a useless piece of hardware. Then secondly, it must meet criteria. It must meet, every locality, you have your approving authorities, your government, and your building plan approval authorities. And then you have your client requirements, then you have costs, and you have the quality of construction. So the first criteria, as I mentioned, is functional. Second is must meet criteria. Well, the third one is what you talk about is that it must look beautiful, because that's what we are. We're architects. If we don't make it beautiful, then can you imagine all buildings will look like prisons? Look like square buildings, look like boat diagrams. And so it must be functional, it must meet criteria, and it must be beautiful. But the fourth one is probably the most important one, and that's the first one that all of us should start thinking about when we design any building, which is to make people happy. In other words, to give joy to the users of the building, give joy to visitors, give joy to the public. So in some ways, aesthetics is one of the justifiable aspects that we need to consider. But you have to make sure that these aesthetics or things that we do to make people happy, are ecologically benign as well. So design is not just greening. Greening is our research, which is our lifetime's work. But more important, when we're designing buildings in reality, we have to find ways in which we can make people happy. And that is, to me, the real function of architecture. So let's say if you're an architect, you design a house for a family. No matter how green you make it, no matter how low energy you make it, net zero energy or net zero waste or net zero water, if they have a miserable life living in their building, then it's pointless. You have actually done a disservice to humanity. And so we should start by designing buildings which make people happy. We did a house about a couple of years ago, and somebody asked published the house in a book, and the first thing they asked the family is, what's it like living in this house? They said, we are living in a paradise. So that means they're extremely happy with the house. And, when people say that about your architecture, your whole purpose, your whole reason of being an architect is fulfilled, because your job is to make people happy. So your responsibility to your client is to make them happy. You have to be built within budget, to the high quality construction, and within the time frame they expect it to be built. But at the same time, you have a responsibility to the environment. So your buildings has to be as green as possible and as low energy as possible. And if you can, it should be net zero energy and net zero water and net zero waste and net zero environmental impact. Those are the key things that we need to consider in ecological design.
Yeah. So, Doctor, it makes a lot of sense why we need to do this, and the pandemic just opened our eyes a little more that we need to become one with nature in whatever form we can. But what are the impediments? Why is it taking so much time to convince, whether it's the authorities or even the builders or contractors, that this makes perfect long-term sense? What's your perspective?
Well, there are many factors. First one is that ecological design is still in its infancy. There are many issues that they have to address, and even though I've been doing this for nearly 30 years, I've only covered, it's only the tip of the iceberg. There are many things to be done. And so very few architects design the way that we do, or do research and design and build in the same way. Most architects think that because they fulfill the green rating system, they've done a green building already, but that is really just legislative way of looking at green architecture. But my biggest issue is with the mindsets of architects. And most of my architect friends of my generation, I mean, you know, they were not brought up in ecology. They do not see architecture as I see architecture as applied ecology, as applied environmental biology. And because of that, it's very difficult to have a conversation with them, and very difficult to convince them of, you know, why I do things in a certain way. So I've almost given up on my generation. But the students of today, they should be taught ecology. They should be taught about energy conservation, talk about, you know, net zero materials, designing for recycling, for reuse, and designing for food production, and so forth. And so they are the future. But the hope is with them, and that we'll take what we do and extend it much further. And so the impediment for second impediment is that people are just not trained to think like ecologists. And because of that, then it's very difficult for them to understand the ecological implications of what they do. Secondly, that's the effect of cost, because, you know, doing a green building costs more than a conventional building. For instance, we tell clients we should budget, if this is your budget, your industry standard budget for this building type, you need to budget an extra 20% or 25% on top of that to make it green. Now, how many clients are prepared to spend this sort of money? The first thing to think about is, you know, well, why should I spend the money? Why should I bother with the environment? And so, you know, budgeting and setting money aside to do that is very important. Then there's the authorities, because authorities, you know, or the institutions, you know, really have to change. For instance, our socio-economic systems, our political systems, and our you know, societal institutional systems all have to change to become green. Now, this is happening. This is happening slowly, and then people are saying that yes, people say that we won't find. The banks will say we don't finance a project if it's not a green, it's not a sustainable project. But we still have a long way to go. You know, people a lot of it's just lip service about what they should be doing. But whose job is it to change the mentality of the people? It can't be us, it can't be me, or it can't be architects, because we are not very powerful people. We're just people who provide a service to produce buildings. And so it's the behavioral changes at the top. The politicians must say, yes, we're going to make this into a green country and make this nation into ecotopia. Our educational systems must change. We must teach people how to think of the world ecologically. All our educational systems must change, our financial systems, our political systems, our management systems, and everything's changed. But it's a major undertaking. It's not going to happen overnight. But the mindset must be that people must be prepared to do this, and this is what I hope will happen.
Yeah, you know, across the world, the term smart city is right now in vogue. People say that, you know, we need to make 100 smart city. For instance, in India, we are looking at a project proposed by the government where we will create 100 smart cities across the country. Why are we missing, while we are looking at the smart factor where the technology is coming in? Isn't not the right time to also bring in the green factor in, so that the future cities are much better and much more livable?
Well, green cities are basically smart cities. It's actually the same thing, except the smart cities, you know, most people who define or think about cities as smart cities are basically smart cities for the benefit of who?
Yeah.
For people, benefit of the economy, benefit of the systems of the technological systems. So if you were to be truly designing a smart city, then it should be smart city to the benefit of nature. That means we should have systems that monitor the biodiversity location, but monitor the water, and all these monitoring systems are available as in existence. You know, GPS, for instance, can tell us which part of the Earth is being destroyed, which part of the Earth is being affected by natural disasters. And we're able to integrate this and have an immediate response system So that once there's a fire or there is a flood somewhere, straight away there is a team of people who can go out and address it and resolve it. Or there's like a pandemic, that there should be total integration at the regional and national level and international level. So, this is what the World Health Organization is trying to do, but it's extremely difficult because each government has its own priorities. And it's it's a huge problem. But a smart city is a green city. If you use all the smart systems for the benefit of not just human beings, not just the benefit of the city systems, but for the benefit of nature.
Again, my last question, you mentioned that you have a lot of hopes from the coming generation. And during the musings discussion, one of the students had, sent us a question in which he said, I'm, entering my whole career span. I'll be starting up as an architecture and a designer. Uh, so where should I look for? Where should I aim? Should it be, critically acclaim ideas and designs and, all of those projects? Or should I do something which will at the end of my career, give my conscience a clean chit that I have done something back and I've done something good? Where is the line, or is there a thing in between? What would be your suggestion to that?
Well, first of all, the first question I ask is, do you really want to be an architect? Because an architect is just a miserable life. You have very long hours, very poor remuneration, not remuneration, which is not commensurate to the effort that you put in. You have clients who treat you very badly. Half the time you have contractors who don't build, and you're fighting with them all the time. And life as a professional architect is extremely difficult because you have to do several roles at the same time. Now, let's say if you are in the car industry, the people who make the car, the production people, are not the people who do the management. Yeah. People the management are people who don't do the sales. People who don't do the sales don't do financial control. But if you're an architect in practice, they were small to medium practice, you have to do everything yourself. You have to do the marketing, you have to do the production, you have to do the sales, you have to do the management, you have to do everything. So can you imagine what sort of life it is as an architect? So my first question is to a young architect is it worth it? Do you really want to be an architect? Because if you want to be an architect, then you must be prepared to accept all the, all the issues that as I mentioned earlier on being an architect. If you're not prepared to do it, then wouldn't it be much easier to to do insurance or or work for a bank or whatever it is, And so if you want to be an architect, you must have a passion for it. You must be prepared to suffer, the slings and arrows of outrageous fortune, as Hamlet was known to have to say. And so that's the first thing. Second thing is, where do you start? Well, first of all, you must have a green heart. That means you must be dedicated to making the environment green. Then if you want to do that, then the next thing you need to do is to learn ecology. Now, at the same time, as I said, you have to do all these functions, marketing, leadership, direction, supervision. And this, if you like, is something that I had to do when I first started practice. We started business in 1976, 1975, 76. And I found that universities, or schools of architecture, like the one, where most of my colleagues are, students, don't teach you how to become a businessman. They don't teach you how to be a businessman on your own as an architect. And so I had to learn how to do marketing, how to learn how to do financial control, how to learn how to sell, how to learn how to manage, how to organize the office, how to learn how to do all sorts of things. And I spent my first, 6 to 9 months attending evening classes at the Institute of Management. So I would advise any architect, if you go out, if you want to be in business, then go and learn how to do business. Go to your local institute of management, or there are a lot of management schools in Mumbai and in India, and attend evening courses, on management. Now, one of the things I did, and I did it too late, actually, I should have done it 20 years earlier, was back in 2001 and 2002, Harvard Business School ran a course, which is a one-week course called Leading a Professional Service Firm. You should Google it. Harvard Business School leading a professional service firm. And it's a one way from Saturday to Saturday. He teaches you everything, but it's very intensive. You have a lecture in the morning, a lecture in the afternoon. You have a case study in the morning, a case study in the afternoon. Then in the evening, you have to study on the case study. Otherwise, you get asked and you don't know how to answer. It's very embarrassing in a room full of people. And the cost at that time, and I did it in 2002, was 13,000 US. That includes your board and lodging, includes your food, includes lectures, includes lecture notes. The only thing extra you have to pay on top of that is the airfare. And obviously it is in Harvard, which is in Boston, and it's great. So I would recommend a young architect, if you want to go into business, learn business. Quick way to do it is to go and attend this course at Harvard Business School called Leading a Professional Service Firm, leading a professional service company. And when I attended it, there were only about, usually the class of about 30 plus people. And the architects, only about 2 or 3 architects and engineers. But the rest are people in the insurance business, in the finance business, in the banking business. And so because they are service industry in the same that we are as an architect service industry. And so you come back, it totally changes the way you look at the business. You walk in the restaurant and you see the number of tables, look at the menu, look at the pricing, you look at the food. You can immediately in your head, you can calculate whether they're making money or not, and how much money they're making. And so it actually changes the perception of the world in the same way that when you learn ecology, the whole way of looking at the world is different. When you walk down the street, you're looking at pollutions. When you look at plants, you can see, the plants turning white, and plants turning white. They're just turning white because there's environmental pollution. So you look at the world very differently. The way you use water, the way you use food, and the way the waste in your house, and also changes your habits because, for instance, one of the first things that really destructive to the environment is fashion. I mean, I have basically, 4 white shirts, 5 pairs of underpants and 6 pairs of socks and 6 pairs of handkerchief and 3 pairs of trousers, and that's it. I don't buy anything else. But why do I need to buy new trousers? I don't want to buy new jackets. We don't need it. But of course, once you do this, then the whole marketing and advertising world then suddenly gets up in arms and says, wait a minute, you're taking away our business from us. But we have to change our habits. We have to change our lifestyle. And so, these are things that we have to do, and that, so you have to learn ecology, you have to change your lifestyles, and you have to learn how to do business. That's if you want to be an architect in business. Otherwise, you could be in a laboratory doing research, or you can be in a university doing research. Nothing wrong with doing that, because we've got to have people doing that sort of research. And I don't have the time to do this. I'm doing research on the run, and I cannot do research properly. And most of the time, I'm running around delivering projects, fulfilling clients' requirements, and chasing for money. And so it is a hell of a life. So you tell your students, or you tell whoever's listening, ask them, do you really want to be an architect? Is it worth it?
Is it worth the effort and worth the toil?
Yeah, do it because you really have passion for it and you want to do something well and make the world a better place. But otherwise, if it's just for the money, you could actually spend your time doing something else and do it better and earn more money than being an architect. Now, we have to rethink also the role of the architect. For instance, the architect business has been, if you look into the Institute of Architects, whether it's in India or in America or in the US or Hong Kong, Singapore, architect has to go beyond the conventional service. An architect has to provide, for instance, an architect can become a developer. Then you have the greater control of your services, greater control of the product you do. And so the architect can be a developer, the contractor can be a builder, can be a joint venture, joint venture investor. we have to experiment a little bit and have to go beyond, the traditional role of the architect. This is my advice to students. Okay, if you just want to make money, try and think about what it is you can make money being an architect without, without losing your priorities and your ethics of being an architect. And so that's what I think. That
That's it, Dr. Ken.
it.
It's an honor to have a chat with you and also have that lecture be part of it. I just hope that more students could join us and they could hear it live. But we'll be recording this, and the recorded version will be played on the website as well as on the social media. So we'll be tagging your team, so you will also be able to see the engagement on that.
Well, send me a copy of the video.
Absolutely.
What you do.
Absolutely.
But I think my officer sent you the press release for my latest book.
No, I haven't received a press release copy, but I'll check.
Okay.
If they can reshare it, I'll ask my team to upload it immediately. We'll take it.
It is called Saving the Planet by Design.
Ah,
And it's
nice.
published by, and then the subtitle is Reinventing Our Cities. But
Okay.
it covers everything that I've said today and more.
Oh, is the lecture the older lecture that you had?
No, this is a new book that came out in February this year.
Oh,
And it is published by Taylor and Francis, Routledge.
and Francis, yeah.
Taylor and Francis, and you go to Amazon.com and you look at books that are authored by me. This is the latest one called Saving the Planet by Design, and I think you should get the students to read it if they can. It's only about about half an inch thick, but it is not. It's a book that's not easy going. You have to read a few times in order to get it, but it took me 3 years to write it. I think it's an important book for everybody to read. Okay, thank you very much. Thank you very much for having me.
Thank you for this.
Cheers. Right, bye.
Have a great day.
Okay, right. Okay, thank you, Hafiz.